shape tomorrow's infrastructure. Enhance precision, lead with sustainable solutions. Masters in Global BIM Management in Civil Engineering and GIS. Enroll now.
Oh, hello everyone. Welcome to today's session, Integrating BIM and GIS for Smarter Road Design and Technical Documentation. Thank you for joining us today. In this session, you will discover how combining BIM and GIS enables more accurate analysis, better informed decision-making, and smoother collaboration across disciplines. My name is Thaisa Figueroa. I'm Institutional Relations and Program Owner here at ZIGURAT, and I'm thrilled to be your host today. So if it's your first time with us, let me make a quick introduction. ZIGURAT is a leading online educational institution with over 20 years of experience in e-learning. Our programs cover architecture, engineering, and technology management, helping professionals worldwide to boost their careers. And we are super proud of our global community. We have more than 20,000 students from over 100 countries. So at ZIGURAT, we believe in unlimited possibilities, unlimited knowledge, future, success, leadership, and imagination. And that spirit of limitless growth begins right here with all of you. So before we begin, I always like to ask our audience, where are you joining us from today? So please, if you can, share with us in the chat, where are you joining us today, from today? I'm here in Barcelona. I'm Brazilian, but I live here in Barcelona. And I would love to know, where are you joining us? So let's try to keep the energy high and stay connected throughout the session. Let me take a look. Antonia, hello, Antonia. So today's masterclass is directly connected to our Masters in Global BIM Management in Civil Engineering and GIS. This program prepares professionals to collaborate globally on real-world infrastructure projects, mastering the three core pillars of BIM excellence: technology, process, and people. So it's a one-year fully online master's that covers the entire infrastructure lifecycle, BIM foundations, GIS and reality capture, road and civil design, construction management, and asset operation, all through an open BIM workflow. So with hands-on case studies, cutting-edge software, and an international faculty of industry experts, the students are ready for roles such as BIM managers, GIS consultants, and technology leaders, driving innovation and efficiency in the infrastructure sector. So the next edition begins in May 2026, so feel free to scan the QR code and learn more about this master program. And now it's my great pleasure to introduce today's speakers, Bruno Busnardo. Bruno is engineering manager at Yakka TDC, and Bruno has more than 10 years of experience in roading and civil infrastructure projects across New Zealand and Brazil. He has worked on major multidisciplinary developments involving highways, land development, and complex civil works. He specializes in delivering projects that positively impacted society, thriving in environments that require strong coordination, problem solving, and stakeholder engagement. His main interests include digital engineering and sustainability-driven transformation, which he views as key drivers of the future of civil engineering. And Bruno is also part of our faculty of the Masters in Global BIM Management in Civil Engineering and GIS at ZIGURAT. Before I pass you the floor, Bruno, I would like to tell something to our audience, feel free to send your questions in the chat. We will address them during the Q&A at the end, okay? So, Bruno, thank you so much for accepting this invitation and welcome. The
Thank you
stage
very
is
much.
yours now. Thank you.
Thank you very much, Susan. And good evening, good afternoon, good morning to wherever you are in the world. Just to pick up from Thaisa, so I am speaking from New Zealand. This is home to me for the past 10 years, and I am originally from Brazil. Um, as Thaisa said, my name is Bruno Busnardo. I'm also a Bentley trainer qualified person from a modeling perspective, and as said, I am a lecturer on the Masters in Global BIM Management in Civil Engineering and GIS, and I am also a master lecturer on our Masters for Artificial Intelligence in construction, and I lead an engineering team at a construction company here in New Zealand named Yakka. Um, so, but kind of enough for me. I would like to think that we don't need to be an expert on absolutely everything when it comes down to our technical knowledge, but we just need to know enough to be dangerous. So this nice little graph here resonates with me quite strongly. This is the Dunning-Kruger effect, and to me, I would just classify myself as a generalist, as an engineer generalist, someone that knows a little bit of everything. It's not a specialist at almost anything, but just knows enough to be dangerous um, at something. And I think the more I think about our master structure here, and I hope that you'll be able to see that in a minute. This is exactly what this is about. It's all about understanding, building information modeling, what it is. It's documentation, naming convention, all that. So what we try to do it is really to bring you on that journey to whatever level you are at any particular space within building information modeling, within a project lifecycle, whether you work at asset management at the very end, or if you work at planning at the very beginning, or if you're a surveyor, or if you're a BIM manager or a designer, it doesn't really matter much because this is a 1 year master program that will just bring you to that journey. So this is like here. It is really to emphasize is that this is a roadmap that we of our program, which is essentially broken down into, I would say, 7 main blocks. So we do have the block 0, which is the welcoming week of our program. That then the classes really start at block 1, followed by block 2, 3, 4, 5, and then the block 6 is just the final submission of the final master project that we have, which is called FMP, followed by a defense. But the book here, it is what it is really interesting. So we have a program that is based on 10 different modules, and the modules have been designed just so you get the learnings from the previous module and you get to apply them on the following module. So you do have to have that sort of the pre-existing knowledge of the previous model in order to successfully go through and follow by and complete the model that you are studying now. Um, and here, I just wanted to highlight that I am a lecturer of 2 modules within this master program, which is module 4 and module 9. So module 4 talks about infrastructure being for infrastructure models, which is all about design. So we dive deep on design, on a road design, if you like. or any infrastructure design, so anything that it is linear, horizontal. We then, once we nail up on our design, block 4 is about creating that 4D scheduling. It's about construction. So if I can summarize, block 3 is about design, block 4 is about construction, how we can implement building information modeling processes, techniques into construction, and block 5 it's all about maintenance. So once once it is built, once an asset, a road, if you like, is built, how can we implement building information modeling processes into that existing asset? So this is generally the flow of things. So at module 4, I teach road design modeling, and at module 9, I ended up teaching as with asset management. So just to start being a little bit more technical here within building information modeling terms. At block 1, we're just gonna have that BIM management introduction. We'll start talking about BEP, which is building BIM execution plan. We'll talk about EIR, exchange information requirements. We'll talk about the common data environment, how we set up a common data environment, the types of common data environment that we have in the industry today. We talk about other documents like our master information delivery plan, which is all about linking that in theory to our final master project, which is a gradual project that we start from scratch and we ended up with an asset that has got all of those steps. So hence the importance of us following up step by step and trying to enjoy as much as we can. The second block, we just diving deep on our terrain, on our digital terrain model, how we add other layers within GIS and all that, and all that is used as a base foundation for me, as in to enable us to do our road design, and that is the area that I I am a lecturer and that I am specialized with. Then we followed that by developing a drainage design, a bridge design. We we also go off on a little tangent at module 6 and we talk about rail design. And then once that design heavy experience is sort of finished, we use all that document and file into our 4D scheduling program, um, which also feeds into our cost estimation 5G part of the project. And that then it is imagined that the asset is built, and then I then start introducing asset management techniques um, within building information modeling into the program. I just hope it is clear our approach to you. I am more than happy to take questions about this because this is a very interesting structure and very hands-on structure, which is something that I like. Now, just to give you a context, if you don't know this yet, building information modeling is all about information, and we are essentially guided by an ISO number 19650, and that ISO, which is information management, it does break it down into several areas and apply it to a project, to an asset, say it has got those two main phases, which is the delivery phase and the operational phase. What I like of this graph is that it also shows the magnitude of the attention of the delivery phase, which to a lot of us it's quite big and significant. You're not wrong. But it also brings another perspective that the operational phase, from a life cycle point of view, it is much, much, much longer. Say, if a big infrastructure project takes from planning to as built, if it takes 5 years, 7 years with funding and all that, an operational asset, the same operational asset, may take 100, 150 years, 200 years. So this is all about capturing the whole of life cycle. And that ISO is also encapsulated within the asset and project management ISO, which is the 55,000, and also the ISO 9001, which talks about organizational management of a company. Now, a key takeaway of today really it is to give you a very good understanding of what building information modeling is and what it isn't. So I just hope that today as you finish this session, this is very clear to you, which is building information modeling, it's all about a combination of three key elements, which is a graphical design, asset data, and documentation. So every single time that people mention to you, oh, BIM, building information modeling, what it is, your mind may go straight up to a nice 3D model, a nice and flashing, singing and dancing 3D model. But it is not all about that. Yeah, it does have that element, which is essentially, a third of it. Yeah, maybe the root foundation of it, but it is not about that just. We also have got asset data, which is, intrinsically linked to the graphical models, and that also leads to documentation. So I'm just applying like normal terms to us. The graphical models may be your DGN files, your DWG, DGN, IFC files, lane XML files. Your asset data, it is anything that pertains in about that. It could be an as-built drawing. It could be also a as-built topographical survey or a maintenance survey. Anything that has got direct relationship to the live data, to the as-built infrastructure that is considered as an asset data. And the documentation, we may have reports, construction scheduling, cost estimation, all that. So, building information modeling is all about those three things. If it is just one, so if you only have a nice 3D model, you may not have a building information modeling per se. So I think this is quite important to understand so we can move forward. Now, um, if we just break that down a little bit further, we we do break it down into delivery and operation. And within delivery, what we have, that combination of those three elements, we've got something that we call a project information model, so a PIM model. And this is a combination of, for example, as a documentation, we got our BIM execution plan, our BEP. We've got our say preliminary design, detailed design, DWGs and all that. And with that, we also have asset data. Any drawing, any DWG is a data that talks about asset. Once once we finish construction, that is the line between delivery and operation, and then we do have the same elements of it, but it goes to the operation phase. So what once was a project information model, now it is an asset information model, and essentially to me, applied to what I'm here to talk about today. This is module 4 and this is module 9. So I am on the verge of those two things. Now, if we dive deep to module 4, which is road design modeling and technical information management. It is essentially broken down into 5 distinct units. Unit 1, and again, once again, we go through a journey. So at Unit 1, we talk about preliminary road studies, what we need to have in order to design a road. In unit number 2, we talk about how we can develop that preliminary design. So it's all about road design and how we can design options fastly, quickly, sufficiently enough to give us good insights, and how we can make decisions about it in order to choose just one preferred alignment. Once that one preferred alignment is chosen, we go and dive in deep into detailing that design. So we just call it road detail drawing, modeling, if you like. Once that's done, we the units 4 and 5 are all about how we can extract information from my design, so from my DGN or DWG, if you like, which is again, I think a big, generally speaking, and historically speaking, a big lessons curve, say, of the majority of the students on this step. So what I'm just going to do now, I'm just going to summarize each one of those areas briefly, just so we can have a good understanding of what it is. So for Unit 1, the preliminary road studies, it's all about data capture. So we will look at mechanisms that we can find data in the data that we need in order to design a road. So it could be transport data. Transport data could mean how busy an area or how busy an existing road is, and what is the cross section that we wanted to have on our road? Is it a 4 lanes road? That is a single lane road? Do we have pedestrian? Is there cycling? So what are those parameters? We also look at planning data, which is what is the existing land use and what is the future land use. We also bring in data such as what is the existing geology of an area? Do we have any fault lines? Is there any area that is known to have soft grounds? What is the rainfall? What's the contour doing? And is there any area that already floods? So let's just go and capture those, just so we can see them, where they are, to do a nice mapping, and then to design our road around it, connecting point A to point B. So we do go through that exercise all together, which is quite nice. And obviously we need to have our topographical survey just so we can have our contours. That is then the foundation of our blank canvas, which enables us to do design a road on. We also talk a lot about on this phase about the design standards, which design standards to use, noting that we are global, so each one of us is sitting on a different place, which we do design our elements based on the standards of that place. So standards may mean something different to each one of us, and we just try to keep a consistency to locate as we located our project in the UK. So we automatically use the design standards from the UK. So all of that combined, we just call I'd like to call as a constraint mapping, and the best way to deal with those different layers, if you like, it is through the application of through the use of a tool of geographical information systems, so GIS. Um, to that, we do use QGIS. We show QGIS and also ArcGIS from Esri. Um, the previous module that only talks about digital terrain module. We dive in a bit deeper on application of that, which is just the beginning of us understanding how we can best use geographical information module at such an early stage, which is within the preliminary road study. That is essentially a bunch of layers or a combination of layers, one on top of the other, within a geographical system, a linear geographical system. And that's the main difference here between the horizontal infrastructure, which we are all about, then with vertical infrastructure, which is a building, which is always going to be located within, 4 or 5 the same geographical information points. We just deal with a little bit differently because in here we are horizontal and we are spread up by chain edges. So once all that is understood, we've got a nice little map, something like this, that which is our constraint mapping that will quite often show our streams or rivers that we have, a dense vegetation, also could show also any other protected areas, something that we cannot simply go there on our design, and then we have to move from point A to point B, say. Once that's known, we just go off and start drafting lots of options. And then we go based on that constraint mapping, based on our design standards, what are the possibilities of it. And then we together go through a decision-making analysis that we just call like a multi-criteria analysis of it to narrow that options down into one option, into one option that we just call to be the preferred option. And we do all that on the program using design two softwares. In a lot of ways, it is one or the other. The students we have designed the program just so the students can choose whatever design software the person wants to do. Some students quite often ended up choosing the software that they're most familiarized with, which is totally fine. Some other students trying to use this as an opportunity to learn a different software. So we offer both, and which is one, it is Bentley based, and the other one is Autodesk based. So it is up to the student to choose, and if the student has got the capability and the capacity to develop both at the same time, that is also okay. So this is just a great opportunity to have a better understanding of those two applications, design two applications. And at this high level design, preliminary design, we do use InfraWorks and Open Roads Concept Station primarily because it gives us a really good understanding from a three-dimensional world of what that option is. So we ended up developing lots of options. So essentially, instead of being a line on the map, as it is on this image, it is actually a road, a high functioning road that has got a level of development, an LOD, within BIM term, up to between 250 and 200, if you're familiarized with the term. And so that is one reason, one aspect of it. It allows us, to quickly deploy and to quickly have an understanding of its footprint, what the road is doing, and how we are bridging, how we are interacting with a existing constraint. And also, and I would say almost as more importantly, it also gives us good insights towards quantities, towards quantification, and if we applied a rate to it, which the design softwares do enable us to do within the design softwares, we are able to come up with a, say, a high-level cost estimation. The key here is that we're just looking to get the magnitude right. What's the magnitude of this option versus the other option? No infrastructure is ever, and it cannot be built based on those high-level design that comes from those high-level design softwares. So we just have to make that very, very clear. Um, and now, from once that is understood, we jumped into our road detail phase, if you like. So we've chosen one option, and we just wanted to develop that option, and then we just take whatever design we've developed from this high level design, and we've imported that into a more detailed design software. So in here, this is all about diving even deeper on the three elements that are consistent of a road model, which is a horizontal alignment, a vertical alignment. Combination of those two lead up to a 3D alignment. So if you're not, a designer, or if you're not familiarized with 3D modeling design, my takeaway here is always break it down to those three elements. It doesn't really matter how fancy and flashy your 3D model is, you can always distill it down into those three elements. So what's the vertical alignment doing for this segment or block? And what's my horizontal alignment doing? Those two things will then generate a 3D alignment. When you take that 3D line, if you like, and by the way, we in here we use that two softwares. Again, same story as before. Bentley based, which is Open Roads Designer, or Autodesk based, which is Civil 3D. We do go through both workflows, so all the students can have that, in-depth understanding of how both design softwares work. Um, and once we have our 3D alignment, what we need to do, we need to develop an assembly in Civil 3D terms, and we also need, and in Bentley terms, Open Roads Designer terms, we need to come up with a template. Once this is done, this gets applied to my 3D alignment. Then I will then have a 3D design. Say this is the backbones of it, and we just go through step by step of it. And a 3D design may look like something like this that we have on the left hand side of this slide. So it is a design, and in here you can sort of just see on that alignment that we have a combination of horizontal alignment, vertical alignment, which leads to a 3D line. That 3D line is then applied a template, a corridor, which then gives us the 3D design. From that, we also start extracting information of something that we call drawing production. We developed site layout plans in longitudinal sections, and we also developed a series of cross sections for that asset. Here, the objective really is not to to train you to be a designer. That is not our purpose. This is really to show you the steps required to come up with a 3D modeling. For that reason, we don't don't often dive into, say, more complex design modeling techniques like intersection modeling, even though this is an intersection, but um, or roundabout modeling, traffic signal modeling, and also super elevation, all that. We don't we rarely go there. This is just because the whole focus is implementing building information modeling within the process, within the workflow. So once the design drawings are developed and done, and the 3D model, we then go start at unit 4. At unit 4, it's all about data extraction. So we need to prepare those models in order for us to be able to take information from it. So in Bentley terms, this is all about starting and assembling and pointing, adding pay item types to our models, to our road model, if you like. And to Civil 3D terms, this is all about adding property sets to it. So it is essentially the same thing, but slightly different naming. So we do have the property sets and we've got the pay item types, which is where we go, oh, this layer, this solid, if you like, of my 3D model. This is a road surfacing layer. And then in here, we also start adding things to the 3D model, which is all about us having an understanding of our classification, which in here is just one as an example, which is a Uniclass 2015 application. That is just a naming convention of it, a naming convention for barriers for anything within a road infrastructure. And also we've also talked about an IFC naming convention. So every single item within that IFC has got a name convention associated to it. And then we just go an IFC site, an IFC road, an IFC alignment, so on and so forth. We just go through that journey. All of that combined simply help us to develop, to export information, which then leads us to the unit 5, which is all about the quantitative data extraction. On that, this is just the activity of us taking quantities out of our model. So we're talking about like corridor component quantities. What's the area of my asphalt? What's the area of my base course? Every single element that you may have designed should be exported in here. Earthworks, cut and fill, all that. And the way that we also do it here, it is, we export that Excel spreadsheet, and more importantly, we also export that to an IFC. So this whole idea is that all of that information can then be translated into an IFC. IFC stands for Industry Foundation Class. If you're not familiarized with that term, I just want in your mind another takeaway to go to, this is how we PDF a design document. Do you know on Word that if you want to send to a client that Word document, you just go create a PDF and then you send the PDF? On design terms, it is the exact same thing. Instead of you sharing your native file, your DWG, your DGN, you share an IFC. It works also best from an interoperability perspective. So an IFC is something that may look like this, and this whole idea of the building information modeling process is, as we select the very same item that we had selected before, I'm just gonna come back, as we selected here, so say this asphalt layer, as we select that asphalt layer, we will have the same properties. So the same properties that I have added into my native file should have come through my IFC. This IFC is then used as an input to develop my construction sequencing, which we call the 4D scheduling, and also to develop our 5-dimension, our 5D cost estimation. So we use the IFC files to build up our bill of quantities, which then just links every single one of those 3D elements to an actually rate, to a construction rate, just so we can have a cost of our asset, of our infrastructure. And in here, I am just talking during construction phase. So this is in a nutshell, a summary of the module 4, which is from memory the most extensive module within our program. That is essentially because of the learning curves that and the journey that we have to go through, generally speaking. Now, once we finish construct our asset, we go module 9, which is a module that talks about asset lifecycle management. In that is essentially just breaking down into 4 units. I am a lecturer of unit 1 and 2, and these are the units that I am going to be focusing the most. But the flow through goes something like this. We start talking about the exchange and the standards, how we can exchange that information from a project information model to an asset information model, so from a PIN to an AMI. And also, and then at unit 2, we talk about how that handover looks like in practice. And then unit 3 just takes all that, puts some strategy of how we will be able to maintain our asset, our road. And then unit 4 talks about a nearly, or like a forward working planning that will give us those insights that will enable us to maintain a road more accurately. So from an asset information exchange requirements, we again just gonna go back to that. We've got our project information model, and in our delivery design phase, we talk about design information requirements. And on our construction phase, we talk about construction information requirements. Design phase, we have a design intent model. And then during construction, we have something that we call a VDC, which is a virtual design construction model. Once we finish construct, we got a different phase that it is an asset that the PIM becomes an asset information model. And to that, we need to have a document named asset information requirement, which is the backbones of it. And on this unit, we developed an asset information requirement ourselves, and then we just go through what it is, what it isn't, and in its intricacies. That's sort of the bulk of it. And once those exchange information requirements are well known and understood by all parties, which is the constructors, the designers, and also the client, we then start, working on the plan. So this is essentially a plan the work and work the plan type of approach, which then leads us to the model handover auditing. And on this phase, if you imagine, we would then, in real world, we would have to go through an as-built set of design development once again, but it's not a design, it's just like an as constructed. 3D laser scanning, redo some solids on our native, perhaps changing and adapting an IFC model. So to that, we talk about something called IDS, which is Information Delivery Specification, which is all about that in terms of what does need to be changed on our IFC models, say, as they are part of my information exchange. And then we benefit from using softwares like Bonsai that enables us just to tweak or to add more information to it, or sometimes we just go back to our native and redo that. That then it is then exported to a spreadsheet format at one way, which is the one that we use. It is a tray COBE format, which stands for Construction Operations Building Information Exchange, COBE, that then talks about everything that you have designed and that has been built. It's got a line on a spreadsheet essentially. And then we use that and we load into a geographical information system to then be managed through a visual way. But in reality, all of this is just a data set, a spreadsheet sitting behind. So I hope that by now you sort of just have got a good sense of the journey that we go through. We start with GIS high level, and then we go high level design, diving deep to our design, and then how we can set up and extract data from that design to construction, how we take that from construction and we put it to maintain the asset. So the key here is that whole journey, and then us going through the journey together for 1 year. So just to wrap it up, my key takeaways that I would like you to take it from today, that early decisions matter. So the choices in the alignment on the vertical, horizontal alignment, and the drainage material and your design matters because it directly influences safety of the road, constructability, and life cycle cost. So the early decisions matter, and that is a very nice graph from Patrick McLamy. If you wanted to have a look, it talks about how building information modeling influences positively into early decisions. And that to me, that's why it is so important that we start implementing that into our day-to-day lives. The second point is that our design is data-driven. It is not really, and it is not just a nice and a flash 3D model. It has to be a data-rich design. So we're just calling this either as a modern modeling through Civil 3D Open Roads Designer. Simply allows for efficiency and compliance with standards and allow for precision modeling. And I'd like you to think of this whole life cycle, which is that the design is the first step in the asset management. So you do have to have that finish in mind and almost starting backwards. So every line that you design, that you draw, it'll be a line item on a spreadsheet that will then require to be maintained in the future. That's how important it is. And integration is the future. Um, as a just briefly touch base, IDS, Information Delivery Specification, which will then lead to us having digital twins more openly into our industry, will support this design data flow to seamlessly flow into asset management systems. Um, so essentially, the quality of our modeling today defines the sustainability of our assets tomorrow. So, the best of the design knowledge that we have now, it will define the future that we have as as um, as as a global humans really living in a global society. Um, with that, I would like to thank you all for bearing with me, and that's all that I had to share today. So thank you. I'm happy
Perfect.
to take the questions.
Perfect. Thank you, Bruno. We are almost out of time, but I think we have time to answer one question that I saw here. So let me read for you. Does the course include an overview? Maybe you already answered it, but I will make it again, okay? Does the course include an overview of BIM and GIS data integration principles and tools? In your work with public transport infrastructure, such as track system and overhead contact lines, we need to ensure that scanned infrastructure data in the GIS environment is compatible with BIM projects prepared for construction and asset management.
Yeah, most definitely. 100%. We do go through all that. The data that we have. So essentially, if you're taking a scan, chances are that you have a point cloud. You receive a point cloud that can then be translated into a len XML, which can then be read to into either GIS or the design modeling. And you can also, on these days, our GIS tools and systems, it does enable IFC reading as well. So this is all about us. We do go through all that, but and also in real world, this is all about us talking to our suppliers, talking to our supply chain, our clients, and whoever is going to be doing my topographical survey, having a sit down and then going through what file formats the company can give us, and also us as a client, and also us as a client being specific on what our requirements are. Hence the importance of having that AIR document, which is an asset information requirement. So if an asset already exists and you're taking a survey, a topographical survey, say, this is how I accept that data as a public entity. It's all about that.
Great.
Good question.
Yeah, perfect. Thank you so much, Bruno. Do you want to leave a message to our audience, everyone that is here, and also everyone that will receive the recording from today's session? So we can finish with your message.
Yeah, I think it's all about those key takeaways that I've said. What we design today, it'll be the world that we're living tomorrow, and in the more accurately we can be on the early days, the better, because early decisions matter, and implementing building information modeling processes and workflows are directly linked to that. And on this masters, this is the whole purpose, that we go through that journey. We often sit as designers, or as clients, or as constructors, or as people who will be managing the assets. So we change our hats as our project evolves, which to me is very unique. I haven't seen or experienced a structure like that before at this global scale, which is very exciting to be part of.
Thank you so much, Bruno. It's a pleasure to have you with us in the faculty board. So I would like to finish thank you, a big thank you to Bruno for such a great presentation and an excellent overview of our master program. And of course, thank you all for joining us today. Stay tuned to our upcoming masterclass and professional development opportunities. Until next time, stay curious, stay connected, and take care.